All right, good morning, everyone. My name is Joel, and I work at GitHub. So creativity is the ability to imagine something new. It is not the ability to create something out of nothing, but to generate new ideas by combining, changing, or reapplying existing ideas. Today, we're going to do just that. We're going to take ideas from React and reapply them in Rails. And in doing so, we're going to take a template that is hard to test thoroughly, is impossible to audit with code coverage tools, makes it difficult to reason about data flow, and fails basic Ruby code standards, and refactor it into a new experimental addition to Rails called Action View Component that is tested thoroughly in isolation, is audited with code coverage tools, only receives the data it needs, and follows the code standards of the Ruby language. And it also happens to be over 200 times faster to test. But first, what even is a view? Views are functions. They input data and return HTML. So how has the Rails view layer evolved over the years? The reality is that it's been pretty stable. Rails still ships with ERB, like it did in 2005. In 2012, Rails 4 added turbo links. And in 2016, Rails 5 added API mode. But in the last couple of years, the winds have begun to change. I think it's telling that DHH said when Rails 5 was released, Rails is not only a great choice when you want to build a full-stack application that uses server-side rendering of HTML templates, but also a great companion for the new crop of client-side JavaScript or native applications that just needs the backend to speak JSON. The reality is that the history of the Rails view layer is one of most of us moving away from it. So what does the view layer look like at GitHub? We're still using ERB. So why isn't GitHub a single-page app like everything else these days? The main reason is progressive enhancement. So while JavaScript makes our user experience more pleasant, most of our app works without it. So why do we do this? There's a couple reasons. The first one is performance. So while most of us here are lucky to be using modern, powerful devices, a lot of our new users are in developing countries, which means they're using low-powered netbooks, Chromebooks, or tablets, which can buckle under heavy JavaScript. Another reason is browser support. Since we don't need JavaScript to run our site, we can simply turn it off for older browsers that are harder to develop for, which makes our JavaScript easier and cheaper to maintain. So how do we do it? We do it with a couple tiers of JavaScript bundles. Our first bundle, for fully supported browsers, just has normal JavaScript. We have a second tier of polyfills for those that need it. And then for unsupported browsers, we only serve a smaller set of polyfills. So when we deprecate browsers, we move them through these 3 tiers of support. So what does progressive enhancement look like in practice? Take, for example, posting a new comment on an issue. You click the comment button, and we have some JavaScript that intercepts the click. And then an AJAX request returns DOM nodes for the sidebar, comment form, and timeline. We then inject these results into the page using PJAX, which, if you guys aren't familiar with it, is basically turbo links. What's great about this is that if JavaScript is turned off, we just make a normal request and reload the page. So what is it like to work on views at GitHub? So I recently worked on adding sticky headers to pull request and issue pages that shipped, I believe, in January. So as part of that project, I got to know this little piece of our user interface that we call the issue badge really well. Now, we use the issue badge to display the status of issues and pull requests. And we use it about a dozen or two places throughout the application. It's part of our design system that we call Primer, which you can think of as basically our own version of Bootstrap. But before we dig into that too much, let's talk about our data model. So when we're talking about issues and pull requests, a pull request is just an issue with an associated pull request object. So all pull requests are issues, but not all issues are pull requests. And we render the issue badge with this partial. I'll give you a second to read it. So depending on the state of the pull request or issue, we render an icon, label, and color. These together display the state of the issue or pull request. So wanting to know more about the behavior of this view, I figured, why don't we just delete it and see what happens? So that's just what I did. And I pushed it up to our CI, and the build passed. So how could this be? The reality is that things are, I mean, especially if you saw Eileen's talk yesterday, a little different in the way we use Rails at GitHub. GitHub is a Rails monolith that just turned 11 years old. So let's talk about scale. We have over 200 controllers, not including our API. We have over 550 models, not including concerns, of which there's about 1,500. And over 3,700 views. So how might this scale affect our approach to testing our views? So right now, our main way of exercising our view code is through controller tests that we've set up to render our views. And in our test suite, it takes 6 seconds to run one of these, not including any setup. Said another way, that's 1 minute to run a suite of 10 cases. So does anyone here know how long the Jeopardy theme song is? It's 30 seconds. There we go. So imagine listening to it twice every time you want to run a suite of 10 cases. At our scale, this just isn't sustainable. So I believe this problem is a symptom of several shortcomings in the Rails view layer. When I asked my local Ruby group this question, the #1 response was data flow. A common data flow error we're probably all familiar with is the good old n+1 query, where we accidentally generate an expensive query in a view. So our example code also has some data flow issues. So for pull request and issue, what attributes do we need from each object? If these are active record objects, we'd be fetching their entire set of attributes, when we may in fact only need 1 or 2 for each object. In addition, it's unclear where the pull request and issue variables are coming from, making it difficult to reuse this partial with any amount of confidence. So another problem is that unit testing views isn't a common practice in Rails. Rails encourages us to test our views through integration and system tests, which are expensive. This is especially painful for partials like our issue badge, as they often end up being tested for each of the views they're included in, which leads to duplication of tests, and I would say really cheapens the benefit of reusing a partial in the first place. Another problem is measuring code coverage. Neither SimpleCov nor coveralls support view code. This, combined with the friction of writing tests, puts our views in a real blind spot compared to the rest of our code. Another weakness is the lack of a method signature. Unlike a method declaration on an object, views do not expose to the values they're expected to receive. So let's go back to our example. What data does this view need to render? Does it need a pull request? Does it need an issue? Should I be able to pass in both? What about neither? Are these values passed in as locals, or do they come from a helper? The reality is that our views regularly fail even the most basic standards of code quality we expect out of our Ruby classes. So let's take another look at that example code. So if this was a method on a class, what aspects might we object to in a code review? Besides it being a super long method, I can think of a couple. Where is octagon defined? Where does this class attribute value come from? It kind of feels like a magic string. Where are pull requests and issue coming from? The reality is that we regularly do things in our templates that we would never do in a Ruby class. So to recap, Rails views are difficult to test, and those tests are impossible to audit with code coverage tools, preventing us from knowing how thorough they are. They make it difficult to reason about data flow, have implicit method signatures, and often fail basic Ruby code standards. The reality is that the existing Rails view layer is a second-class citizen these days. So with all these shortcomings, perhaps it isn't much of a surprise that a new way of building views has taken hold in our community: React. So React is all about components. A component encapsulates a piece of user interface, making it easy to reuse. So here's one way of writing hello world in a React component. So React components, at a minimum, implement a render method that returns HTML, and then arguments passed to a component are assigned to the props object, which is accessible within methods on the component. So here's an example of what the issue badge might look like as a React component. Like our template, the component renders an icon and label wrapped in a state-specific CSS class. Another dimension of the React architecture is types. The prop types library allows React components to express some expectations about the data they receive. So in this case, we're expecting an issue with the isClosed Boolean to always be provided, and a pull request to sometimes be provided, and if so, with the isClosed, isMerged, and isDraft Booleans. What's great about this is that we can then reference the isClosed Boolean on issue without fear, as our type check will guarantee that it is present. Another advantage of React is how it simplifies data flow. By passing values into views instead of objects, React encourages us to write functions without side effects. Another great thing about React is how easily components can be tested in isolation. So let's have a look at a sample component test. So here's an example test that renders the component directly and then asserts against the output. So what's great is that this test runs without touching the database or the controller layer, which means that it's really, really fast. So to recap, React has components that render HTML, types that give us confidence in our inputs, simplified data flow, and lightweight testing and isolation. Which is really too bad, because it's not compatible with our progressive enhancement architecture that we use at GitHub. But what if there is a way we can incorporate some of the benefits of React into Rails? So before we start doing some refactoring, let's write some tests, because we want to make sure that we're not going to break anything. So what might it look like to test our view? So in each case, we're doing three things: setting a class name, icon, and label. So to start, let's add some traditional controller tests for each state. We'll start with the test for the open issue badge. We'll assert that we have the correct class name, icon, and label. And now we have test coverage. So let's delete the view, like I did earlier, and see what happens. We have failing tests, which means we can actually do some refactoring. So what might a component look like in the Rails world? I think it would make sense to make it a class like everything else in Ruby. So let's call it badge inside the issues module. And how might we call it in our view? The Rails way would be to use the existing render syntax. So let's see if we can get our first test to pass. So first, we'll add a method to our component that returns the open issue badge from our partial. We'll call it HTML, as render that React uses is a loaded word in ActionView. And we'll run our test. So this is interesting. It looks like ActionView render doesn't like being passed our component. Imagine that. So let's teach it how to handle it. Now, short of forking Rails and changing the original definition of action view-based render, let's write a monkey patch. Not kidding. So in our monkey patch, we'll redefine render so that when we pass in our component, it calls our component's HTML method. And let's run our test again. Undefined method octocon? That's an interesting error. So remember our code review comment about not knowing where that octocon method came from? Now our code is asking us the same question. So back in our component, let's tell it where to find it. And we'll run our test again. So now it looks like it can't find the CSS we're looking for. I wonder what our component is rendering at this point. It looks a little something like this, escaped HTML. So while it might be tempting to use something like HTML safe here, I think it might be a better idea to just try and reuse the Rails rendering pipeline and all the safety guarantees that it gives us. So first, let's move our template into a method called template. And then in our HTML method, we'll run our template through ActionView's ERB template handler. This effectively mirrors how regular Rails templates are compiled and then executed in the view layer today. So let's run our tests again. And we're green. Time to ship it, right? But let's keep moving along. So the next test is for a closed issue, which should have a red background, a closed icon, and a closed label. So let's run it. It can't find the red CSS class, as we haven't handled this case yet. So let's go back to our template that renders the component. Well, we're already passing an issue here, but we aren't doing anything with it yet. So let's change that. So first, we're going to need to update our monkey patch to take the arguments we're passing into render and passing them into an initializer on our component. So then we'll need to define that initializer on our component. In this case, if you can remember back to the slide about the data model, we're going to need to let pull request be nil, as not all issues have pull requests. So now that we have an issue, we can render it, we can reference it in our template. So if we run our new test, it's green. But something interesting just happened there. We gave ourselves an interface for our view, which means no more implicit arguments. And just like that, we're making even more progress on our code review. So next, let's take the rest of our partial and just drop it into our component and see how the rest of the controller tests do. We're still green. But you know, something doesn't feel quite right about this template. The first 2/3 handle various pull request states, while the last third handles issue state. It really seems that we have two components here, not one. So since the view that calls our component knows whether it is dealing with a pull request or an issue, how about we split this out into two components and let the view pick which one to use? You know, that's not so bad. Based on whether the issue has a pull request, we can render either the pull request badge or the issue badge. So back at our monkey patch, we're going to need to do a couple things. We're going to need to update our conditional to look for both components. But let's check on our tests. They're still green. So let's go back to our code review. Remember that comment about magic strings? Both our issue badge and our pull request badge are rendering that same state UI element from our design system. So why don't we make that a component? So our state UI element really just has one option, color. So if it was a component, that would be our single argument. So let's build it. We'll call it state inside the primer module. And then we'll also need to update our monkey patch to handle yet another component. But you know, this is getting a little weird. Perhaps we're missing an abstraction here. What we're really trying to say with this line of code is, am I dealing with one of these new components? I think it might be time for a parent class. And we'll call it ActionViewComponent. So let's take our new parent class and update our existing components to inherit from it. Then we can simplify the conditional in our monkey patch to instead just check if the argument is a subclass of ActionViewComponent. So now that we have a parent class for our components, we can also reduce some duplication. So an easy candidate is our HTML method, which doesn't have any component-specific logic. So let's move that to ActionViewComponent. And let's check in on our tests. We're still green. So back to building our new component. This one's a little different. We're passing it content as a block. So let's start by writing a test. Now, while we could probably just rely on our existing controller tests for this, wouldn't it be nice if we could test this new nested component directly by itself? In React, our tests were able to render our component directly and then assert against the resulting HTML. And ideally, we'd be able to do the same in Rails. Render the component directly, and then assert against the resulting HTML. All we would need is a way to render our template in line, which is pretty easy to do with application controller. We can render our template in the same code path as a normal view, and then parse the result in Nokogiri, which will make those assertions a lot easier. So let's run our test now. It looks like something that expects a class is receiving a hash. And it looks like our test helper is actually to blame here, passing a hash into render. So as it turns out, ActionView's render method accepts a couple different types of arguments. So we're going to need to go back to our monkey patch and update our conditional to make sure we're dealing with a class. And then let's rerun our tests. That's a lot closer to what we're looking for. Where we were expecting our content to be rendered, we just got an empty string. So let's think about how we might make this work. When we're passing content into our component, what we're effectively saying is, render this block in the context of the current view, and then wrap the result in the component. So how might it look to implement that? So first, we're going to need to update our monkey patch to accept a block argument. And then we're going to need to update our render step to first instantiate the component. And then, if a block has been passed, render it in the context of the current view. And we'll do this using ActionView's capture helper. And then we'll assign the result to an accessor on the component. At that point, our component will know about the content, so we can render it. So now that we're expecting all components to have this content accessor, let's go back to ActionViewComponent and declare it there. And then it's just a matter of taking our component and updating the template to render the value of that content accessor. So let's check in on our test. And we're back to green. But now that we have content, what about setting the color? So let's start by adding a color argument to the initializer. But what values do we need to handle? If we look at our design system documentation, it looks like we can specify 3, green, red, and purple. Otherwise, the component defaults to gray, which you've probably seen as our new feature, draft pull requests. So let's go back to our component, and let's capture those relationships in a constant. This gives us a clear mapping between the default value and not applying a CSS class, and the color values and their respective CSS classes. What's great is that the keys of our hash also represent the entirety of the values we should allow for the color argument. So how can we enforce this in our component? Let's start with a test. So we'll assert that when passing in a color we're not expecting, chartreuse, that an error will be raised, and that it will be raised with a message in a format that should be suspiciously familiar to all of you. So let's run it. And we'll make sure it fails. So how might we ensure color is one of the expected values? We're in Rails, so this is a solved problem. And it's called active model validations. So back in our component, we can use an inclusion validation to check that color is one of the keys on our constant. To make this work, we'll need to define an attribute reader. And an action view component will need to include active model validations. And then all that's left is to go back to our monkey patch and add a step to validate our component before we render it. So let's run our test again. We're back to green. So now let's add a test to make sure we're setting the right CSS class based on the color, and that it fails. So previously, we just had the CSS class hard-coded in our template. But now that we can be sure that color is one of the keys in our hash, we can safely use the hash to look up the correct CSS class and use it in our template. And we're back to green. But let's take another look at that documentation. I think we might have missed something here. We're supposed to have a title attribute. The reality is that for most of the components in our design system, CSS isn't the only interface. There's a lot of things that we have to take into account, like for accessibility reasons, for example. But this is something our original partial never accounted for. So let's make sure that doesn't happen again. And we'll do that with a test that passes in an empty title and expects a validation error. And we'll make sure it fails. Then it's just a matter of adding a presence validation for the title attribute, and we're right back to green. So let's see how our controller tests are doing. Missing keyword title? I think we might have just caught a regression. We never updated our consumers of this new primer state component to pass in that new required title argument. So let's add the title attribute, and we're back to green. So when it comes to data flow, we were mainly concerned with our views unintentionally querying our database. But what if we could avoid passing in active record objects altogether? That would eliminate that risk, right? So let's start with issue badge. Right now we're passing in an issue object, which is from active record. But the only thing we're doing with it is calling the closed predicate method. So as you can probably imagine, our issue model's interface is much more than just this one method. But yet we're passing in the entire object just to get this one value. So if we look at the very abbreviated implementation of issue, you can just see that this closed predicate method is just checking whether the value of state is closed. So what might our component look like if we passed in the state value instead of the whole issue object? So first we need to update the initialize method to accept the state value instead of the issue object, and add a validation for the possible values of state. But then looking at our template, what if we could extract each branch of this to just be derived from the value of state? We could clearly express the relationship between the state and the combination of color, icon name, and label. And then we can take our template and extract the values from the constant instead of having nearly duplicate branches of our template. So let's run our tests, and we're still green. But what about our pull request component? How might we decouple it from active record? So looking at the template, we're relying on 3 predicate methods: merged, closed, and draft. So can we pass in a state value like we did for the issue component? Looking at another abbreviated model, things aren't so simple as they were for the issue model. While we do have a state value, whether the pull request is a draft or not is independent of that value. And in fact, it's just stored as a Boolean in our schema. So which means is we're going to need both of these values to render our component correctly. So let's start with some tests. And what's luckily enough for us, we now have an easy way to unit test our components. So in this first one, we'll assert that when we pass in those state and isDraft values, that we render the correct label, title attribute, and icon. So let's run them. So it looks like our component is still expecting the old argument. Let's go update it. So first we'll need to update the initializer to accept the state and isDraft values instead of the pull request object. And then let's take our template and extract the title, color, octocon name, and label into methods. And I'll spare you the details of those right now. So what's interesting here, if you take a good look at this component, is that it's really similar to our React mockup. It's almost uncanny. So let's see how our tests fare. We're back to green. So remember how React encouraged simple data flow, minimizing side effects? By passing values into our components instead of objects, we're seeing similar benefits. And remember how we were unable to get code coverage reports for our views? Our demo app here now has a perfect score in SimpleCov, and perhaps more importantly, if we dig into the report, we can see that all of the branching exercise in those methods I spared you the details of is being exercised. So what are we waiting for? Let's ship it. Crazy, right? So as it turns out, we already have. These components that we've written today have been in production since March. And as of last week, we're also rendering repository topics and language badges with Action View component. So what have we learned from using this architecture in production? As we implemented these components in numerous places throughout our views, we exposed several cases where we forgot to set that title attribute, much like the test failure we ran into earlier. The reality is that by using standard Ruby constructs, like required arguments, we've been able to enforce the interfaces of our components, and as a result, now have a single, standardized, reusable implementation for these UI components that makes it easier for engineers to work with our design system. So what about performance? In our test suite, our controller tests take about 6 seconds for loading a page and asserting against its content. So what about these new unit tests? They clocked in at around 25 milliseconds running in the same suite. That's over 240 times faster. Said another way, our test that used to take 2 Jeopardy theme songs to run now barely makes it past the first note. So creativity is the ability to imagine something new. It is not the ability to create something out of nothing, but to generate new ideas by combining, changing, or reapplying existing ideas. By taking ideas from React and incorporating them into Rails, we've taken a template that was hard to test efficiently, was impossible to audit with code coverage tools, made it difficult to reason about data flow, and failed basic Ruby code standards, and created a new way of thinking about the view layer in Rails that enables us to write efficient, isolated tests that are audited with code coverage tools, only work with the values they need, and follow the code standards of the Ruby language. All of these things give us a higher confidence in our view layer, and perhaps most importantly, make it a first-class citizen in Rails. Thank you. I have 6 minutes for questions if anyone has anything they want to talk about. Yes, go ahead. Yeah, funny story. Did you see Eileen's talk yesterday? Yeah. So we have a rule at GitHub. Oh, sorry, the question. The question was, do we have any plans to push this up into Rails? So first of all, whenever we invent something in GitHub at this point, it is the default rule at the company that you have to plan to upstream it. That is especially true if you're writing a monkey patch that's running in production. Yeah. Go ahead. Where is it pushed to upstream? So if you go to my website, there's a demo repo that actually has the exact source code as it's running in production right now for everything we wrote today. There are some small performance tweaks that I didn't have time to cover today. They're very minor, though. Sure, so the question was, we have thousands of views. Where do you see this pattern making sense versus not? Is that correct? So I think the most obvious application is using a design system like we have, or if you're using something, say, like Bootstrap, something that you use over and over and over again that, I don't know, we care deeply about accessibility at GitHub. So having consistency in the way our UI is rendered is really important in that regard. So we've started with our design system, but we're working actually towards a pretty specific goal, which is we have kind of elements throughout our application that are reused, and the one we're working on right now is what we call the repo list item. We do it 27 different ways right now. I counted. It's literally like if you see a list of repositories, that thing. So we're building our way up into that at this point. So that's why you see us doing repository topics and the language badge. We're probably about a month away from rendering all of those the same way with this everywhere in the app. The reality is that that's low-hanging fruit, because what we didn't talk about today is like managing like complexity with this pattern. There's things on the React side that we have yet to try and apply in that regard. I think we'll start to see that as we build the repo list item, though. I'm excited to see what we kind of discover as we go. Go ahead.
Do your components support caching?
Caching? So the question was, do the components support caching? Yes. So that you can inject caching into this. At this point, we do caching outside of the component. We're rendering it inside normal ERB templates at this point because we're just doing small, reusable pieces of our UI. That will become more important as we, work our way up. So the question was, how are we doing, like, say, more interactive things? You can think of this as like when you click a drop-down and it dynamically loads some HTML, for example. Very lightweight JavaScript. Keep in mind that for a lot of our, like a good chunk of our users, they don't get JavaScript. So the answer to that is as minimally as possible. Because anytime we add a feature that requires JavaScript, what we're effectively saying is some people aren't gonna be able to use this. So we do it with little sprinkles. And ideally we do it in a way that, like, if you don't have JavaScript enabled, there's still a way to accomplish that goal. You might not be able to do it as efficiently, say making a new comment and not having the whole page reload. But we really try and stay away from building workflows that you can only accomplish with JavaScript. So the question was, have we looked into what the bulk of our 6-second runtime is, overhead is for our tests? We have somewhat. I think the short answer to that is that I really tried to focus this talk on things that are universally applicable. There's a lot of things, if you saw Eileen's talk yesterday, that we do internally that are unique to our code base that are more relics than things that are of any interest. That is part of the overhead. I know part of it is just some specific dependencies we have. Yeah. Cool. Well, thank you very much, guys.